So check out this question here, guys. It says that if 18 raised to the power 2 over 3 times 12 raised to the power 1 over 3 equals to 2 raised to the power m times 3 raised to the power n, we should find the value of m plus n. Now, when most students see this, they already know the law of indices, that this 18 raised to the power 2 over 3, it will now be the cube root of 18 squared times the cube root of 12 equals to 2 raised to the power m times 3 raised to the power n. But if you try that, you will get something like, you won't get the answer. You know that the cube root of 18 will give you a decimal 2 point something. So addressing it from that angle is not the best thing. What I would advise any student under this situation to do is this. We know that if you want to get 18, you say, like, 18 is 2 times 9, like 9 plus 9, 18, and 9 is 3 times 3. So what you should do is 2 times 3 times 3 raised to the power 2 over 3, just for now, times, if you want to get 12, we know that 12 is 6 times 2. 6 plus 6 will give you 12, and what will give you 6 is 2 times 3. So this will be 2 times 2 times 3. All of this will give you 6, will give you 12, sorry, equal to 2m times 3n. So if I want to take it out, it will be 2 raised to the power 2 over 3 times 3 raised to the power 2 over 3 times 3 raised to the power 2 over 3. This is how it's written, because if I still want to join it in a bracket, I can just bracket open. So I'm just like expanding the bracket now as just opening like this. Then I write for this same thing, 2 raised to the power 1 over 3 times 2 raised to the power 1 over 3 times 2 raised to the power 1 over 3 equals to 2m times 3n. Okay, so what's the next step? The next step will be like, let's move all the 2's to one side, let's carry all the 3's to the other side. So I'll say 2 over 3 times 2 1 over 3 times 2 1 over 3 times 3 2 over 3 times 3 2 over 3 times 3 1 over 3 equals to 2m times 3n. So what do we do? You know, from the law of indices, if I have all the bases to be the same, I can just take one base and add all the powers together. That's according to the law of indices. For instance, maybe right over here I have AB plus AC. It will not be equal to AB plus C. I'm just giving you an example. When the bases are the same, sorry, times. When the bases are the same and it is multiplied and they have powers, you can just take one base and add the powers. If it's multiplication, not addition, I mistakenly wrote addition. Then for this same one, you say 3 2 over 3. Because it's multiplication, you can just take the powers and add them. 1 over 3 equals to 2m times 3n. So if we add everything here, what will it give us? We know they have the same basis, so definitely it will be one LCM. So we say 2 plus 1 plus 1 times 3. The LCM will be 3. 2 plus 2 plus 1 equals to 2m times 3n. So hope you can see it. This will give you 4 over 3 times 3 raised to the power 2. This will give you 5 over 3 equals to 2m times 3n. Remember, the question says that we should find m plus n. We've already been able to simplify our what we got to have. See what we got before now. See what we now have. So they say we should find m plus n. So this is our m, this is our n, where m is equal to 4 over 3 and n is equal to 5 over 3. So if we want to do m plus n, it will give us 4 over 3 plus 5 over 3 is equal to, find the LCM, what will give you 3. 4 plus 5, which is equal to 9 over 3. 3 will go into 9 how many times? 3. Because we know that 3 times 3 is 9. So our final answer is actually 3. So that's the answer for this question. Most, like I said before, most people would just have written it like this: cube root then squared plus, they will not find the cube root, try to find the cube root of 12. But if you do that, let me get my calculator. If you do that, what will you get? You get cube root of 18. You see, you get a decimal, and if you try to square that, like, it just won't make sense. If they want you to use calculator, they would have said so. But in such a question as this, it's best not to use calculator when you're having decimal like this. It's best to solve it the old-fashioned way and get your answer. So that's for this question.